Okay, so this is the chapter about which we were discussing, and this is chapter number 10, the dual nature of radiation and matter. And in this chapter, we are here discussing about the work function of the matter. Right. When I talk about the work function, dear students, it is very clear that the work function itself represents the extent of the energy, right? The amount of the energy. So now when I talk about the amount of energy, then work function will be what? Let's talk about the work function. And if I talk about the work function, which obviously includes the word work, and when the word work is there in it, then it simply represents some type of energy associated to it. Now, as previously you already have discussed about its definition, which I'll once again revise, recall you, make you get recalled to this. So the concept of the work function simply indicates it is the minimum amount of energy that is required by an electron to just escape the metal surface. For an example, if you see from here, what I have done, I have taken a metal piece. This is something called the metal piece, right? And what is happening over here? These are the solar radiations, right? And solar radiations, as you already studied in your previous classes, that solar radiation itself themselves are actually the extent of energy. And by the Planck's quantum theory of radiation, E is equal to h nu, right? And when this h nu amount of energy fall on the metal surface, it energizes this electron and will make this electron to come out of this particular metal. Once when it is coming out of this particular metal, because it is coming out, surely it should be having some velocity. And that velocity will surely be producing another form of energy that is known to be as the kinetic energy. Right. And that kinetic energy is given by half mv square, where m is the mass of electron and v is the velocity with which it is emitting out. My dear students, if you simply see the amount of energy which is coming from the solar radiations is h nu, part of it will be taken by the electron of the metal surface to get ejected out. And after ejection, this particular energy will be in the form of the kinetic energy. It means there are two energies which comes into the in which first energy is h nu naught, which is represented by w naught. And this w naught is the same thing about which we are discussing here. And this w naught is actually known to be as the work function. That is h nu naught. Further, this h nu naught actually represents the threshold. H nu naught actually represents the work function, where this mu naught is known to be as threshold frequency. Now, what is threshold? Once when you talk about the concept of threshold, dear students, then this threshold actually represents that minimum value of the frequency, which necessarily is required in order to make an electron to come out, right? It is that minimum value of the frequency which is necessarily required to make an electron to get ejected out from the surface of the matter. Whereas W naught, which you see is here, this W naught represents the work function. So work function, which is W naught, is actually equal to h nu naught, where h is, you already know, I hope, is Planck's constant. And Planck's constant was given by Max Planck, right, during the explanation of the Planck's quantum theory of radiation, which you surely would have studied in chemistry, chapter number 3 in class 11. But now let's move on to the next. So threshold frequency is very much clear to you, I hope, I expect. After this, in this chapter, chapter number 10, the next topic about which you will discuss is electron volt. Now, what is electron volt, dear students? Electron volt also represents the extent of energy. Electron volt also represents the extent of energy. Now, how it is energy? Let's talk about it. Because you know the word volt, when I already encircled it over here, the word volt itself represents that it has something to do with the potential difference. So anyone can get confused that why it is written to be as a volt, and when it is written volt, and then it surely be having something to do with the potential difference. But my dear students, to make it clear, I am simply going to explain you how it has something to do with an energy. You already know that potential is equal to work done per unit charge. I hope that you know this. And in case if you do not know, then I tell you that this potential is equal to work done per unit charge. When you cross multiply this charge, you will get Q into V, that is equal to work, right? Because this Q into V is equal to work, and in place of Q, I am writing here electron. So electron into volt is equivalent to work, right? So now, because I have written here electron volt in this expression, in this particular statement, framing. then this electron volt itself represents not the potential difference, but the energy. So EV is an unit of energy. Once when I talk about EV, dear students, what is electron volt? So electron volt is equal to firstly the magnitude of the electron, that is the charge of electron, that is 1.6 into 10 to the power minus 19 multiplied by 1 volt, right? So now if anyone may ask you, sir, please explain, please define what is electron volt, because they will not ask you that, okay, this is 1 electron multiplied by volt, you can simply place the value and get the answer. When the CBSE is going to ask you such simple type of question, it may ask you a definition for 1 mark that explain what is electron volt. So in that context, what you will have to write down? You will have to write down 1 electron volt is the kinetic energy. Now let us be very clear. Here electron volt is what? It is the kinetic energy. So 1 electron volt is the kinetic energy gained by an electron when it is accelerated through a potential difference of 1 volt. It means now when you are providing the potential difference of 1 volt to an electron, right? When you'll be providing the potential difference of 1 volt to an electron, what will happen? That electron will start moving. And once when a thing will start moving, what type of energy it will possess? It surely will be possessing the kinetic energy. So dear students, this concept needs to be very clear to each and every one of us, right? What we need to be very clear with is that the electron volt firstly is not the unit of potential difference. Secondly, it is the energy acquired by an electron when it is accelerated through the potential difference of 1 volt. Which type of energy it will be? It will be a type of it will be a type of the kinetic energy. And its magnitude is equal to what? If we simply say, student, its magnitude will be equal to what? 1.6 into 10 to the power minus 19 joule. Why I'm writing joule is only because the unit of the work done is joule, because coulomb into volt forms the joule. So I simply, instead of writing coulomb volt, I'm writing here joule. So dear students, this needs to be very much clear to each and every one of us. The next very important concept which we discussed in the previous class was the electron emission. So I already have told you previously that the electron emissions are of 4 types, which you will have to study in your class 12, out of which only photoelectric emission is important. I hope you can understand. All the things here are not playing the vital role of explanation. So dear students, electron volt. Now what electron emission? So electron emission is of 4 types. The first very basic category of it is thermionic emission. The word therm means heat, right? The word therm means heat. When you'll be heating a metal surface, an electron starts ejecting out from the metal surface, then you call it to be as thermionic emission. The second one, field emission or cold cathode emission. So what is field emission? Field emission, it means simply you'll be applying some electric field, and because of this electric field, electron will get ejected out of the metal surface. You can call it to be as field emission. The third category is the photoelectric emission. Now the word photo represents light. The word photo here represents the light. Electric means electron emission. So when you'll be making the light, pay attention, just see in the diagram. When the light falls on the metal surface, it energizes the electron and electron get ejected out. So what is happening here? When the light falls on the metal surface, electron get ejected out. So this is called photoelectric emission. And the fourth category of it is secondary emission. In secondary emission, what used to happen? The first moving electron comes, strikes the metal surface, and throws the electron of the metal surface out of the metal. So this is called the secondary emission. So dear students, this needs to be very clear to each and every one of us. Now, let us move on to the next thing. When I talk about all these 4 types of emission, the next thing we'll have to study about is called photoelectric effect. Photoelectric effect. Now let us talk about the photoelectric effect, dear students. You may write down the definition first in order to make it very clear. The definition will be when the light of suitable frequency illuminates a metal surface. When a light of suitable frequency illuminates a metal surface, electrons are emitted. electrons are emitted from the metal surface, the phenomenon is called photoelectric effect. The phenomenon is called photoelectric effect. So, my dear students, let's be clear with this particular topic. Now, what is photoelectric effect? One thing is very clear: photo means light, electric means emission of electron. Effect. So, this is an effect which makes the electron to get out of the metal surface. This is an effect in which what happens? In which electrons of the matter will get ejected out. So, with the help of what? Photo, with the help of light. So, what is happening in this process? This is an effect in which electron get ejected out of the metal surface when the light of suitable frequency strike on that particular surface. So, dear students, this concept needs to be very clear. Now, in order to understand this, what we will be doing? Let us make a diagrammatical representation. So this is some diagrammatical representation, right? This is some metal surface, and this metal surface, with the help of some wire, may be connected here like this. And this is electroscope. This is electroscope. So I hope you already know about what is called electroscope. Electroscope is a device in which there is actually the gold leaf electroscope, in which there is a leaf. Leaf means, like, these are the leaf. These are the leaf. So what is happening when the light, ultraviolet light, strikes on this metal? When the ultraviolet, this is what H nu, that is the amount of light which is falling in, right? And what is this plate? Usually it is taken to be a zinc plate. You can take other plates also, but zinc plate will be better. When the light, when the ultraviolet light, when UV light falls on the zinc plate, what will happen? Because of this falling of this light, because of this falling of this energy, what will happen? The charges which are freely available on the zinc plate, what will happen to those charges? They will start moving. And you already know, when the charges move, when the charges, actually charges do not move, actually charges drift in the conductor. So what happens when the charges drift? They produce the current. They produce the current. If the charges will be moving in the forward direction, current will be produced in the backward direction. Right? If the electrons, usually, if the electrons are moving in the forward direction, current will be produced in the backward direction. So what will happen when zinc comes under in contact with this light of uh, energy, means you can take E is equal to H nu, where nu is what? Frequency of radiation. H is the Planck's constant. When this amount of energy falls on the zinc plate, it will energize the free electrons of the zinc plate. They start drifting inside and leads to the production of the current. Once when the current will start getting produced, what will happen? Charges will start moving. And when the charges will start moving, this gold leaf electrode, this is what? Gold leaf electroscope. This is what? It is a device. It is a device which is used to detect charges. Gold leaf electroscope do what? It is a device used to detect charges. So when the light of some suitable frequency strikes the metal plate, it will energize the electron which will be available on the zinc plate. And what will happen? These electrons will start moving. These electrons will start moving. And once when the electron will start moving, what will further happen? This will further leads to the production of the current, and this current, the production of the current leads to the development of the charges on the surface, and these charges can be detected with the help of gold leaf electroscope. So my dear students, what we were talking about? We were talking about the photoelectric effect. Photoelectric effect is what? It is a type, it is an effect in which what usually happens, it is an effect in which when the radiation, when the light radiation of some suitable frequency strikes on the metal surface, it will leads to what? It will leads to the ejection, movement of the charges. It will leads to the drifting of the charges in the conductor, just like the zinc plate, which is indicated, which is shown in this diagram. When the electrons will start moving in the zinc conductor, what will happen? The Because of the movement, because of the drift of this charges, there will be the development of current. This current leads to the movement of charges in the wire, and when this current flows in this wire, this will make the charges to get accumulated and can be deduced, can be detected with the help of the gold leaf electroscope. So dear students, This is what usually happens in the photoelectric effect. Photoelectric effect. It is an effect in which electrons get ejected out, emitted out from the surface of metal when the light of suitable frequency strikes on the metal surface. I hope this point is very much clear to each and every one of you. In case if it is not, please you may raise your question, right? You may raise your question and can let me know so that I can just tell you the answer of your doubts. Dear students, before moving to the next point, just write down the basic definition, the very fundamental definition, right, of the photoelectric effect, as well as what are called the photoelectrons. So let us write down the definition of it. The phenomenon of electrons, the phenomenon of emission of electrons, the phenomenon of emission of electrons from a metal surface, the phenomenon of emission of electrons from a metal surface when electromagnetic radiation, when electromagnetic radiation of suitable frequency are incident on it. It is called a photoelectric effect. It is called photoelectric effect. Full stop. The photo-generated electrons are called photoelectrons. The photo-generated electrons are called photoelectrons. So my dear students, now photoelectric effect, let me clear you this definition again. Now, photo means light, electric means emission of electrons from the surface of metal effect. So this is an effect in which what usually happens, an ejection or emission of electron will take place from the metal surface. This is what used to happen, right? The photoelectric effect is that type of an effect. Now what further will happen? Photoelectrons. Now, what are photoelectrons? There is a difference between photons and the photoelectrons. Photons, they are the energy coming from the solar radiations in the form of light. They are called photons. But photoelectrons are not similar to the photons. So be very clear with it. These two are different words. Do not get confused with the photons and the photoelectrons. Photoelectrons are those electrons which are emitted because of the light from the metal surface, whereas photons are coming in the form of light, just striking the surface, energizing the surface. Just like the solar radiations coming from the sun, coming to the atmosphere, energizing, leading to the greenhouse, and ultimately increasing the productivity or the cultivation activities. That is photon, right, which will be in the form of some energy. So there is a wide difference between the photoelectrons and the photons. So be a little clear to the two different things. Do not get mixed with the two things. Dear students, now let us move on to the next thing. The next thing about which we will be talking is a very small topic we will be taking right now. So the next topic about which we will be discussing here today in this class is dual nature of radiation. Let us talk about this. A few topics in between I already have skipped. The basic reason of those skip is because they were now not taken into the consideration for the CBSE's board class syllabus this year. But I will surely gonna teach you in the upcoming class. So with it, what next I will have to teach you today is something called the dual nature of radiation. So let us talk about this. So the next thing about which we will be talking is dual nature of radiation. Let us talk about this dual nature of radiation. No doubt, my dear students, you surely would have studied this topic in your chemistry class 11th, but that is means I'll have to explain it to you in some different regards of taking physics into the consideration. So, dear students, what usually happens? Here I'm writing some basic phenomenon which you surely be knowing about, and in case if not, I'll surely gonna explain you later on. So the phenomenon like interference diffraction, polarization can be explained on the basis of wave nature of light. So these are a few phenomena which can be explained on the basis of the wave nature of light. These can be explained on the basis of the wave nature of the light, right? So what further will we have to take into the consideration? I hope now